Have you ever wondered what life would be like if the Earth was shaped like a donut? Picture it, our planet as a colossal cosmic pastry. It's a whimsical thought, isn't it? But let's take this one step further. What would such a change mean for gravity, climate, and life as we know it? Would it be a sweet existence or a whole lot of trouble? Intriguing questions, right? So, let's dive into this delicious yet complex hypothetical scenario. Before we reshape the Earth, we need to understand its current form. Our home planet, in all its majesty, is essentially a sphere, albeit slightly squashed at the poles and bulging at the equator due to its rotation. This shape isn't by chance but a result of gravity, the force that pulls everything towards the center, shaping the Earth into this smooth, rounded form. The spherical shape of Earth has profound benefits. For starters, it allows for the even distribution of gravitational forces, making conditions right for life as we know it. If Earth were any other shape, gravity would behave differently and life could be, well, a little topsy-turvy. Next, the Earth's rounded shape plays a pivotal role in our climate systems. The spherical form ensures the sunlight is distributed unevenly, creating temperature differences that drive our weather patterns. Without this, we wouldn't have the diverse climates and weather phenomena we experience. Lastly, the Earth's shape directly affects life. It enables the planet to have a magnetic field, protecting us from harmful solar radiation. Without the Earth's magnetic field, life would struggle to survive. So, you see, the spherical shape of the Earth isn't just aesthetically pleasing, it's also fundamentally crucial to gravity, climate, and life itself. Now that we have a grip on our spherical Earth, it's time to roll it into a donut. Scene script. Gravity, the force that keeps us grounded. But what happens when the ground is a donut? Imagine for a moment a donut-shaped Earth. How would gravity work? Well, the answer is not as straightforward as you might think. Gravity, as we know, pulls everything towards the center of mass. On our spherical Earth, that center is neatly tucked away at the core. But on a toroidal, or donut-shaped Earth, things get a bit more complicated. This Earth would not have a single center of mass to pull everything towards. Instead, it would have a whole ring of centers running along the inside of the donut. This means that gravity would pull you towards the nearest part of that ring. If you were standing on the inner edge of the donut, you'd be pulled towards your feet, much like on our current Earth. But if you were on the outer edge, you'd feel a pull sideways, towards the inner edge. This would lead to some strange phenomena. For instance, if you were to climb a mountain on the outer edge, you'd feel as if you were climbing sideways rather than upwards. And, if you were to jump, you'd be pulled in a curve rather than a straight line. But that's not all. The strength of gravity would also vary across the surface of this donut Earth. It would be strongest at the inner and outer edges, and weakest at the top and bottom of the donut. This varying gravity could lead to some truly bizarre scenarios. Imagine playing a game of soccer where the ball's trajectory changes drastically based on where you are on the field. Such a world would indeed be strange and fascinating, but it's important to remember that it's all hypothetical. Nevertheless, it's a fun thought experiment that challenges our understanding of gravity and the world around us. With gravity out of the way, our next stop is the climate. The scene script. Climate, the long-term pattern of weather in a region. But how does this pattern change on a donut? Let's imagine for a moment a world where our planet shifts from its familiar sphere to the shape of a morning pastry, a donut. How would this transformation affect the Earth's climate? First, let's think about the hole in the center of our donut Earth. This hole would create an inner ring of land, an intriguing climatic region. The sunlight would hit this inner ring at a more oblique angle, which means that it would likely be cooler than the outer ring. The inner ring would also be shielded from wind patterns that typically help distribute heat around our spherical Earth. This could lead to a unique microclimate, perhaps a perpetual spring or fall-like environment. Now let's consider the outer ring of the donut. Here, sunlight would strike more directly, creating hotter climates. But remember, our donut Earth is rotating, just like our spherical Earth does. Therefore, the outer ring would have a sequence of day and night, and the varying intensity of sunlight throughout the day would lead to different climatic zones, similar to what we see on our Earth today. But what about the curvature of the donut itself? The curvature would be more extreme than on a spherical Earth, which could result in more drastic weather patterns. Storms might be more severe, with stronger winds and heavier rainfall. It's also possible that the unique shape of our donut Earth could affect ocean currents, which play a significant role in our climate by redistributing heat around the planet. So, a donut-shaped Earth would certainly have a unique climate with a variety of different zones and potentially more extreme weather patterns. It's a fascinating thought experiment, isn't it? it's also a reminder of how the shape of our planet plays a crucial role in determining our climate. Now we've weathered the climate, let's explore life on our donut Earth. Scene script: life as we know it is unique to our spherical Earth. But how would it evolve on a donut? Imagine this: if the Earth was donut-shaped, life as we know it would face some intriguing challenges and opportunities. For starters, the gravitational differences across the planet would create a vastly diverse range of habitats. The inner rim, with its lower gravity, could support tall, lightweight creatures, perhaps something akin to our world's birds. On the other hand, the outer rim, with stronger gravity, might be home to robust, heavyset organisms built for withstand the pull. The climate variations would also play a significant role in the development and evolution of life. The extreme temperature differences between the inner and outer rim could result in species evolving unique adaptations to survive. For example, life forms in the colder outer rim might develop thick fur or blubber, like polar bears or seals, while those on the warmer inner rim might evolve to be more reptilian, harnessing the sun's heat for energy. Let's not forget about the hole in the middle of our hypothetical donut Earth. This unique feature could create a whole new kind of ecosystem. The constant exposure to sunlight might lead to the development of photosynthetic organisms that float in the air, similar to our world's plankton in the sea. Conversely, it could also create a zone of extreme radiation, potentially harmful to life. Despite these challenges, a donut-shaped Earth could also present opportunities. The greater surface area compared to a spherical planet could potentially support a larger population. Moreover, the varying gravitational forces could inspire innovative methods of travel and transportation, perhaps even making flight a more common mode of travel for its inhabitants. In conclusion, while life on a donut-shaped Earth would undoubtedly be different, it's not entirely implausible. Evolution has a knack of finding a way, no matter how strange the circumstances. Whether we'd have sky plankton, gravity-defying birds, or sun-basking reptiles, one thing's for sure: living on a donut might be a challenge, but it sure is an interesting one. We've reshaped the Earth, defied gravity, weathered the climate, and survived the donut. What's next? On this whimsical journey, we've transformed our familiar spherical home into a celestial donut. The implications of this transformation are vast and intriguing. Let's take a moment to recap the highlights of our exploration. First, we delved into the gravitational changes a donut-shaped Earth would entail. Remember, gravity pulls everything toward the center of mass. So, on a donut Earth, the gravitational pull would be strongest at the donut's equator and weakest at the poles, creating an entirely different experience from our current gravity. We then explored the climate implications of a donut-shaped Earth. With the inner curve receiving constant sunlight, the climate would be significantly hotter, while the outer curve, with its varying degrees of sunlight, would have a more diverse climate. This could lead to a fascinating variety of ecosystems, each uniquely adapted to its particular slice of the donut. Next, we pondered life on a donut-shaped Earth. With such a drastic change in gravity and climate, life would need to adapt in unimaginable ways. Species might evolve to thrive in high or low gravity zones, and new forms of life could emerge, adapted to the extreme climates of the inner and outer curves. Our civilization, too, would need to adapt, from the way we build our cities to how we travel around this donut world. But let's not forget, this is all hypothetical. The Earth is not a donut, and it's highly unlikely it ever will be. This journey was more about exercising our curiosity, stretching our imaginations, and appreciating the incredible complexity of our planet. Our journey to the donut Earth ends here, but the universe is full of possibilities. Until next time, keep